Hello, everyone. So, let's get on to the main part of the lesson, which are the medians of a triangle. So, simply put, the median of a triangle is a segment from the vertex to the midpoint of whatever the opposite side is. So, let's look at our three vertices, A, B, and C. In vertex A, the line is being drawn towards CB, the opposite side, hitting the midpoint D. So, the line segment AD is a median. Similarly, with vertex B, the line is being drawn towards the opposite side AC, hitting the midpoint E. So BE would also be a median. All triangles have three medians that are concurrent, or in like common language or simple language, all these medians meet at a point called the centroid. And we typically label the centroid G. Now, these medians and centroids give us a lot of interesting properties about triangles, how to solve problems with them. It's even useful in fields like physics and engineering. So let's try to discover what some of these interesting properties are. So, let's look at our first problem. 7.16. Prove that the medians of a triangle divide the triangle into 6 triangles with equal area. So let's start by making a triangle. And if you're on GeoGebra, you can use this polygon tool. You can make your 3 points of a triangle. So this, and connect to get the 3 points. The only thing I'm going to, really change up is the labels of the points. So I'm going to call this A, and this will be our B, and this one will be C. Alright, now we need to draw the medians. That means we need to create midpoints on all the sides. Now, if you're on GeoGebra, you click this midpoint tool and click on each of the sides of your triangle. Now, if you're not using this, if you're using pencil and paper, you can just take a ruler and measure halfway across, and you'll find the same midpoints. So, our midpoint of AB is I, AC's midpoint is K, BC's midpoint is J. Now we just have to draw the medians. So I'm going to take the segment tool, draw my segment from A to J, from B to K, and from C to I. And notice they're all meeting at this point, right in that middle, which we will not call L because it's the centroid. We will call it G. Now we have our basic diagram. So, how can we get started? Well, first of all, let's just write out everything we know about medians, which is that the medians go from the vertex to the midpoint of each side. So, J must be the midpoint of BC. So that means that JB and JC are the same length. And if I is the midpoint of AB, then IB and IA are the same length, and so on for AC. We have AK equals KC. So I know those lengths are equal. And that's about all I really do know. It wants us, well, let's notice we have 6 triangles. We have triangle BGI is 1, IGA is 2, AGK is 3, KGC is 4, CGJ is 5, and BGJ is 6. So we do have our 6 triangles. Now, how can we show that they all have the same area? They even look really different. Well, in area, we always need base and height. So if I can show that the base and heights are the same, then we should be good to go. So let's take one of the 6 triangles. How about AGK? Triangle AGK. Now, what would the base be for AGK? Well, it could be any of the 3 sides, but I think the obvious choice would be to pick AK, since that has a defined measurement. So, what other triangle has that same measure as AK? Well, CGK has that same length at CK. So if I said that CK was the base at CGK, they would have the same bases. So I'm going to say triangle AGK and triangle CGK have the same bases, or base lengths, I should say. The fact that AK is equal to KC. Now, I need to show, do they have the same height? Well, the height is from the top point of the triangle straight to the bottom. So, what is the top point of AGK? Well, if AK is the base, G must be the top point. So, I'm going to take my segment tool and draw a line that is about perpendicular to the base. Now, I'm having a hard time kind of seeing where it would be. So what I'm actually going to do is the perpendicular line would get me the same thing. If I draw a line that's perpendicular to this base AK, it's going to automatically make that altitude for me with the 90-degree angle. Because the reasoning is because your altitude / height has to have that measure of 90 degrees when it crosses the base. So, and let me get it to show up. Let's see, I'm gonna call this intersection point M, we'll say. I'm just gonna drag it a little closer like that. We can make a segment GM, and then I can get rid of this big excess line that's not really relevant to my problem. Good. So now I have this point M and the segment GM that will be my height. Again, I noticed because I drew the perpendicular line, and whatever line is perpendicular to the base has to be the height. So, AGK has a height of GM from the top of the triangle all straight down to the ground. And we have to also notice that this is the height of CGK. If I measure from the height of CGK, top is G, the base is KC, straight down would hit GM. So they also have the same height. Also have the same height, that being GM. And if they have the same height and the same lengths for the base, then we can conclude that the areas must be equal. So area of AGK is equivalent to the area of CGK. Again, the formula for area, well, one of them is 1/2 base times height. And if the height and base are the same, naturally the areas must be the same. So I'm actually going to color the 2 triangles in the same color to signify to me that I have already proven that they indeed have the same area. So the 2 triangles in red have the same area. So I'm already accomplished a little bit. So now I need to show what other two triangles might have the same area. Well, I think the natural choice might be to go with, well, let's say, how about AIG? Triangle AIG. Now, what triangle would that have the same base as? Well, I notice AI and IB are the same. So maybe BGI have the same base, and they do. IB is the base of BGI. AI is the base of AIG. So I can determine that these two triangles have the same base. Whoops. So, what was it? Triangle BGI. Or BIG. Have the same base lengths. That being AI and BI. Now, do they have the same height? Well, let's use the same technique as before. I'm going to draw from the top point G to the base, which would be somewhere around there, so that it would make a 90-degree angle. And we already used this point M, so I'm going to change it to N, just to make the writing a little clearer. So, it's easy to determine that BGI has the height of GN. But what about AIG? Well, if I kind of focus on that triangle, I'm going to make it, let's say, this nice purple color. What would the height of that triangle be? Well, the base is AI. That means the top point is G. And from the top straight to the ground is also GN. So, in fact, they do have the same height. So, they also have the same heights. That being GN. Thus, since the bases are the same and the heights are the same, we have that the area of AIG is equivalent to the area of BIG. Same height and same base. So, let's just get rid of some of this extra stuff I do not need anymore. And I will also shade in the other triangle, that same purple color, to show that they have the same area. Okay. Now, I'm not going to explain how the last two have the same area, because I would expect that you can get it at this point. That I'm just going to use the same technique we've been doing. So I'm going to just assume that BGJ and JGC have the same area. Now, we've proven that pairs of triangles have the same area, but how do we know that they're all the same area? In fact, they all look quite different. So I'm going to say the purple triangles have an area of X. The yellow triangles will have an area of Y. And the red will have an area of Z. And now my goal is to show that all these must be the same. X equals Y equals Z. How can I show that? Well, let's just use the same technique that we've done before. How about we find two triangles with the same base and the same height? Now, I can't use any of the 6 individual ones, so let me use a larger triangle. So, looking at my diagram, let's say I picked point A as my starting vertex. And I wanted that to be where my height was drawn from. Well, that means the height would hit the opposite side to A, which is BC. So if I took my perpendicular line tool, because the perpendicular line at the vertex gives me the height, and I say I want the perpendicular line from A to BC. Well, whoa, it's all the way over there. But maybe if I just extend BC a little bit, there we go. Now it's a little bit more clear about what my height actually is. So the 90-degree angle is formed here. And I'm going to call this, I don't know, Q. So AQ is the height that I'm trying to work with. Well, what triangles have a height of AQ and also have the same base? Well, I just drew the height from A to where the segment BC was. And if I extend BC infinitely and I draw a perpendicular line from A, that hits the point Q. So AQ is the height of anything that contains the base BC. So I have two triangles that have that. Triangle AJB and triangle AJC. Notice they have, if I'm considering, like for this one, AJB to have a base of B or JB. So I'm going to say they have equal bases. So we have the one base being JB and the other base being JC. That's respective. So that's the base here, and AJC is the base JC. And I also just shown that they have the same height and the same height, which is AQ. The areas then must be the same. So the area of AJB is equivalent to the area of AJC. Now that, if I add up the areas, AJB has an area of X plus X plus Y. And that's equal to AJC's area, which is Z plus Z plus Y. Well, if I subtract Y on both sides, that would cancel out the Y's. And if I simplify, I have 2x equals 2z. Divide by 2 on both sides. And now I have that x is equal to z, which is definitely something that I'm looking for. So, in fact, now I know that x and z are equivalent to each other. Now, you might be wondering, well, how can I show that they're the same as y? Now, I'm not going to do the whole thing because this video has gone on long enough, but you would just use a similar technique that I just used. So, get rid of some of this stuff. And instead of using A as your height, why not use B as your height for this one? So, to find the height again, we want that perpendicular tool, B, and then my height would be at AC, the opposite side. That means And again, I'm not doing a full proof. I'm just going to give you the starting point on how to get it. But you can compare now the triangles A, B, K, and BKC. You could easily prove the same way we just did that they have the same areas, which means we could set up that, well, ABK is x plus z, so 2x plus z equals, and then BKC is 2y plus z, and we would end up getting that x is equal to y, thus proving that they're all equal to each other. Now, huge proof, very deep, but it's very important because it establishes that now we have this important property. Get rid of that the medians of a triangle divide the triangle into 6 triangles of equal area, where we know that y is equal to x is equal to z. So each of these triangles have the same exact area, and in some future problems I can show you exactly why that is so useful.